Hello, welcome to Accounting Hub. I'm Professor George Scarpin, PhD in Accounting, and our topic today is multicollinearity on regression analysis. So, what is multicollinearity? It occurs when there are strong correlation among the independent variable, and they can predict each other better than the dependent variable. When significant multicollinearity is present, it becomes difficult to isolate the effect of one independent variable on the dependent variable. The signs of coefficient may be the opposite of what they should be, making it difficult to interpret regression coefficients. P-value can be inflated. And then, if the correlation is more than 0.7, positive or negative, may indicate multicollinearity. We have another metrics to measure it, but it is not available on Excel. And then what should we do? Delete one of the variables. So work with only one. For instance, let's go to our Excel file. So here we have actual data of the price of soybeans and stock stock index, Nasdaq Composite and S&P 500. So I want to check if the soybeans price is related to Nasdaq Composite or S&P 500. So let's check. Remember, regression analysis, data analysis, regression, the dependent variable, 250 days, soybeans, and then Nasdaq Composite and S&P 500. Let's call it regression 1. So this is our, adjusted R square and adjusted R square. Okay. And then here we have both significance, p-value of both is the same. However, it is positive related to S&P 500, negative related to Nasdaq Composite, but there are some evidence that these two index are very correlated. They are stock index based in the US stock prices, so maybe they are there is some correlation. So let's test it. Out of sheet 1, let's call it data. And by the way, this Excel file is available. The link is in our video description. And it's free to download it, so enjoy. How do we find the correlation? Data analysis, now correlation. Correlation, Nasdaq and S&P. Labels in first row, yes. And then new worksheet, so correlation. Whoops. See? 0.97. The maximum number is 1, either -1 or +1. So they are very positive related. Greater than 0.7. So we should delete 1. So let's copy and paste. And now it's the same as or almost the same. Let's consider only S&P 500. And then we will consider only Nasdaq Composite. So let's do it here. So only Nasdaq Composite. So let's go. Data analysis. Regression. Soybeans. Dependent. Independent. S&P. And then let's call it regression S&P. You don't need to copy and paste. You could work with these, only changing the columns. What? Whoops. This one is wrong. So the X, J. Okay, now will work. So here 34, however, the p-value is good. So the model is not that good, but the S&P is good. So, okay, it is related to the stock prices, but there are a lot of other data that should be considered. And then let's go to the Nasdaq Composite. Now, soybeans. And then regression, Nasdaq. Okay, better, 43. P-value is good. So probably the Nasdaq Composite, so this model is probably the best one. So, but again, the R square is low, so we should add more variables. But now we don't have multicollinearity anymore. So that is how we deal with multicollinearity on regression analysis using Excel. Okay guys, thank you so much for watching this video. Questions or comments, leave them here or email me. And have a very nice day and God bless you.